Hello friends, I welcome you in lecture number 27 on relations. In this lecture we are going to discuss another representation of a relation which is known as relation matrix. In earlier lectures we have seen how we can obtain graph of a relation and how we can represent relation using its graph. Here we are going to discuss another type of representation which is nothing but matrix of a relation or relation matrix. We will see how we can represent given relation as a matrix. So for that first we discuss one example and then we will see the definition of relation matrix. Here I have taken two sets, set having three elements x1, x2, x3 and set having two elements say y1 and y2, and this R is a relation from x to y. We can see that all the ordered pairs of a relation R are nothing but ordered pairs from the Cartesian product x cross y. That is, R is a subset of x cross y, therefore R is a relation from x to y. Now to find out the relation matrix or to represent this relation as a matrix, first we have to concentrate that our relation is from which set to which set. Here relation is from set x to another set y. So first we will prepare the table in which we will consider elements of x on this side. Here we have three elements. So I am writing x1, x2, x3 here, and we will write down elements of set y on this side. That is, they are headed by rows, and these elements x1, x2, x3 are preceded by columns of this table. Now we concentrate on the ordered pairs which are present in our relation. Here x1, y1 belongs to R. That means x1 is related to y1. So here if x1 is related to y1, then the entry corresponding to that ordered pair is always 1. If x1 is related to y1, I am putting 1 here. Now another ordered pair possible here is x1, y2. But x1, y2 is not in this relation. That is, x1 is not related to y2. So corresponding to this ordered pair, I have to write 0. So if some element say xi is related to another element say yj, then we will consider this ijth entry as 1. And if xi is not related to yj, then ijth entry is 0. So all the entries in the relation matrix are either 0 or 1. That is, it is a 0-1 matrix. Now we start from this x2. So possible order pair is x2, y1, and x2, y1 is present in this relation. So here we put 1. Then we have x2, y2. So that is also present here. So here we write 1. Then x3, y1. x3, y1 is not present in this relation. So here we put 0. And x3, y2 is present in the relation. So here we write 1. So first we can prepare this type of table, and then the entries of this table can be written in matrix form, and that is the matrix of a relation 1 0 1 1 0, 1. This is nothing but relation matrix, and we will denote it by m suffix r. So entries in the relation matrix are nothing but this type of entries we have. Say in general we have ijth entry is denoted by mij. So mij can take only two values, 1 and 0. Mij equal to 1 if element xi is related to element yj, and mij equal to 0 if xi is not related to yj. Here I assume that I have a relation from set x to set y, and suppose set x has m elements, set y has n elements, then we will have m by n matrix. And if xi is related to yj, we will consider ijth entry equal to 1, otherwise entry is 0. So it is very easy to obtain the relation matrix. We just have to remember this condition, that if order pair is present in our relation, then entry corresponding to that order pair is 1, and if order pair is not present in our relation, then we put 0. So we will obtain 0, 1 matrix. So that I have written systematically here. A relation R from a finite set X to a finite set Y can also be represented by a matrix called the relation matrix of R. Suppose I consider set X having m elements, set Y having n elements, and suppose R is a relation from X to Y. So to write down the relation matrix of R, first we are preparing a table whose columns are preceded by a column consisting of successive elements of X. That means elements of X are written here. This column, all the columns are preceded by this column, and elements of Y are headed by rows. So above all the rows we write down elements of Y, and before all the columns we write down elements of X if we have a relation from X to Y. That is the meaning of this line. And rows are headed by a row consisting of the successive elements of Y. That means above all the rows we will write down elements of Y, and before all the columns we will write down elements of X. Then if xi is related to yj, suppose I have some xi here and some yj here, and if xi is related to yj, then we enter a 1 in the ith row and jth column, and if xk is not related to xl, then we enter a 0 in the kth row and lth column. If we assume that the elements of x and y appear in a certain order, then the relation R can be represented by a 0, 1 matrix denoted by this notation: m suffix r equal to mij, where mij is 1 if xi is related to xj, and mij equal to 0 if xi is not related to xj. Here I should write yj, because elements of y we have taken as y1, y2 up to yn. The matrix obtained in this way is called the relation matrix. So I have taken another example also, that suppose I have a matrix, a relation from set A having 3 elements to set B having 2 elements, and relation is defined in this way. We have all those ordered pairs AB such that A is from set capital A, B is from set capital B, and condition is that A is greater than B, and R is a relation from A to B, that is R is a subset of A cross B, and from A cross B we are considering all those ordered pairs for which first element is strictly greater than second element. So first we can write down the possible ordered pairs in this relation R. So we can check for each and every ordered pair in the Cartesian. So I fix 1 here, and I will make this type of ordered pairs. Order pair 1, 1, that is not in R because 1 is not greater than 1. Then order pair 1, 2, that is also not in R because 1 is not greater than 2. Then we fix 2 and we vary the second components. So I have 2, 1, so that is present in R because 2 is greater than 1. And another possibility is 2, 2, but 2 is not greater than 2, so 2, 2 is not in R. Then we have ordered pair 3, 1, that is present because 3 is greater than 1, and order pair 3, 2, that is also present because 3 is greater than 2. And I have to write down the matrix representing this relation. So for that, first I am preparing the table. Let me draw the table first, or construct the table. And on the left side here I will write down the elements of this set A. So here we have 3 elements, 1, 2 and 3, and above all the rows we will write down elements of set B. So here I write 1 and 2, and now we check for each and every possible order pair. So first possible order pair is I fix 1 and vary these two as second components, 1, 1. So 1, 1 is not present here, so I put 0. Then 1, 2, that is also not present, so I put 0. Then 2, 1, that is present, so I write 1. 2, 2 is not present. Then 3, 1 is present, and 3, 2 is also present. So this is our relation matrix. From this table we can write down that matrix of a relation is first row is 0, 0, second row is 1, 0, third row is 1, 1. So it is very easy to obtain the relation matrix from the given relation. Sometimes we are given relation matrix and they ask to write down the relation corresponding to that matrix. So this is the example in which we are given the matrix of a relation and we have to decide that which ordered pairs are in the relation are represented by this matrix. So here we can write that this set A has 3 elements, so I can write down A1, A2, A3 here, and elements of B I can write here, B1, B2, B3, B4 and B5, and we will search for ones corresponding to these entries. I start with first A1 element and I will search in this row that where I obtain 1. So here I obtain 1. So because this entry is 1, A1 and B2 are present in the relation R, or A1 is related to B2. So in the our relation I will mention A1, B2. This order pair is present in this relation because this entry is 1. So A1 is related to B2 and there is no 1 in this row. Then I check for A2 as first component, and here I can see that there are 3 ones here. So corresponding to this one order pair is A2, B1. So that we write here. Then corresponding to this one we have A2, B3. So that also I have to write. And corresponding to this one order pair is A2, B4. So we have finished for second entry A2. Then we check for third element A3. So here also I have 3 ones. So A3, B1 because there is a 1 at this position. Then corresponding to this one order pair is A3, B3. And corresponding to this one ordered pair is A3, B5. So in this way we can write down the relation from the relation matrix also. So this is all about this session. Here we have discussed that how to write down the relation matrix from the given relation and how to write down the relation from the given relation matrix. And in upcoming lectures we will be discussing more things related to relation matrix. Thanks for watching.